Hello. Uh, this video is going to cover some basic information on Autodesk Eagle. Now, Autodesk Eagle is a program that is used to create circuit board schematics, convert those into board layouts, and then take those board layouts and convert them to Gerber files, which can then be processed as CAM files, basically that cuts out the shape of the circuit board and also cuts out each of the individual pieces and lays down some of the metal material that is used in circuit boards. So we're going to be covering all of that. So to start out, let's talk about how to download Eagle. So when you go to download Eagle, first thing you do is you download Autodesk Eagle. If you go to download Autodesk Eagle, it'll take you to Autodesk.com. This is a free download. This one doesn't actually require even a student subscription. You can just get Eagle for free no matter what. Usually it's assumed that you are a hobbyist. This version, the free version, is limited only to basically top and bottom two signal layers, and it is about a 12 square inch, so a little bit more than 3 inches square board area. Now, for most of the times in the applications we have, 3 inches by 3 inches is pretty huge, so not really dealing with that size. You'll need to make sure that you have the correct operating system. Go ahead and hit download. You'll have to install it. It's a fairly fast install. Now, when you go to open up Eagle, the starting screen for Eagle kind of looks like this. What you have over here is you have your tree on the left side, which are the different types of files that can be uploaded into Eagle. You'll notice that I have a projects folder over here where I already have a couple of projects. Usually what I do is I try to organize my schematics by different types of projects because it helps me keep it organized in that regard. So first thing you do, opening up Eagle, you go into File, New. I'm going to create a new project. This new project is going to be called Circuit Board. If I were you, I would encourage you to make it a little bit more specific to the project you're doing. Maybe name it the group name that you have. Maybe name it something else. But for me, I'm just going to call it Circuit Board because this is a tutorial video. Now you'll notice that under the project for Circuit Board, I don't really have anything. If I double click on this, it doesn't really take me anywhere because it's not something that has any executable files in it. So I have to do one more, new schematic. I've got circuit board selected. I hit new schematic. This is just going to pull up what a schematic looks like. Now here, up here at the top, this gives you your scale in inches. So here my origin is somewhere around, oh, it's right there. That's listed on the screen. This is my origin. This is my 0, 0 position. Over here, this is about 3 inches away. This is about 3 inches away. It doesn't really matter as much on the schematic piece because schematics you can make as large as you want. But we will have to keep that into consideration when we go to do our board, which is going to be this button right there. So the steps to making a circuit board is, first of all, you have to complete the schematic. Now I'm going to go ahead and assume that you already have drawn up the schematic. You have the circuit that you want, you know what the components are that you want to make, and then merely taking that and copying it into Eagle is pretty easy. So the way that you import items into Eagle is you have to go down here into Add Part, and it's going to pop up a window here that has a bunch of different options that you can search for. Now, part of the process of searching through these is you've got to know how to search for it. So here, if I type in star star resistor, star star, it should give me a list of all of these resistors. There are other ways of searching, but I use the star star resistor method. So here, there are a lot of different types of resistors. Now, every single resistor component that is made, every size, every width, every length, every lead length, those are all included in here. Now the resistors that we use here at Doane tend to be a little smaller. They're only about a centimeter, about 12 millimeters long. And so what I'm going to do for my circuit board is I'm going to pick a a style of resistor that only has either 12 millimeter separation, maybe I might go as much as 16 millimeter separation. I don't need it to be all that much. So I got to keep that in mind when I go to build my board, is how are my components going to look. Now looking through here, there are a lot of different types of resistors. If I click on here, this will show you, this is the schematic layout, this is what it looks like, and this is the board layout. So here, this is actually a resistor that operates between two pads. You have two pads that lay down. This is what's called a surface mount component. Surface mount components tend to be a little bit more difficult to work with than through-hole resistors. Through-hole resistors are the ones that, just like a circuit board, it has two metallic leads that you shove into a circuit board and then you solder the bottom side. What I would suggest is that without having a reflow oven here at Doan, it's just best to do through-hole component right now. So we're going to be looking specifically for through-hole resistors. Now this is a version of a resistor that you can put in that all it is just this. You got to be careful about using this because you'll notice it doesn't have an associated board schematic that comes with it. That is a problem. That's something that you do not want to deal with. You'll notice that these types of components are ones that have very high popularity. They're going to tend to be the ones that you look more into. And here this will give you the sizing too. So here, 5 millimeters. If I were to measure that out just roughly, it's about 12 to 15 millimeters in here. And I already said that's kind of the distance that I want. So here this REU02, it's under the RCL distinguishment, which I think you can actually find by looking for RCL. RCL, REU, I guess you can use the RUS too, which is down here, if you would prefer to be more US. And it's going to be closer to the top up here. This is the same exact component. So you know what? I'm going to be US. We're going to grab the RUS component. It is again in the RCL division up here. So I open up the RCL, open up RUS, go down to RUS. Let's see if I can expand this out a little bit. 0207-10. I believe 10 stands for 10 millimeter component. You could use a 12 or a 15. Again, the only difference is going to just be that lead size, the distance between those leads. Here, 10 is a pretty standard. It's a very close spacing, so you could go with 12 or 15, but I'm going to stick with the 0207-10. So I hit OK, and you will see that now my cursor has a resistor on it. When I click, that resistor stays put. If I were to click again, I could put down a couple of resistors. And then I hit escape to go back to this screen, and OK, or cancel. Well, I hit cancel to get out of here. Okay, so now we're back to this. As we're developing our schematic for this diagram, here each of these are automatically given some kind of name. If you, whoa, I have to grab my clicky tool. And if you go to it, there are a number of different edits that you can do. You can rotate it, you can move it, you can mirror it, you can give all of these different pieces to it. You can even assign a value. So here my value for R1, I could say that this is 10 kilo ohms. And what you'll see is that that value pops up underneath it. Hey! Go back to my selection tool. You're going to have to constantly be selecting your selection tool. Hey! You have to click like right in the center of it. You can change attributes. There's even a way of naming it up here, changing the name. So I don't want to call it R1. Maybe I call this shunt resistor, and that's what I want it to be called. This will actually show up, shunt 10K, that will actually show up on the circuit board itself. So make sure to pick names that actually are meaningful. If R1, R2, R3, R4 are meaningful to you, go for it. And when you want to change, you have to click on this crosshair right in the center, right click on it, and that's how you open this up. If you just right click on the side of it, it'll beep at you often, which becomes very annoying quickly. Eagle is not the most user-friendly interface, unfortunately. All right, so we've got our components in. Let's say we've renamed them. I'm not planning on renaming them. The next piece that you have to do is that you're going to want to put what's called a net between these. A net is basically just it's a series of lines. So I'm going to go pull out my pop-out window, and I'm going to go to net. And now what this will do is, if I hover over the end of one of these components, it'll turn into a circle, and then I can connect them to each other. Yay! So now I have 3 resistors all connected to each other. Okay, and I can do this for capacitors as well. I could go in, add a part, search for star star capacitor. Just leave it as star star capacitor. Again, going to RCL, these are going to be your most common components. You can look at the different types, and here's the American symbol for capacitors. Here's a very common type of capacitor. This is a through-hole component because it's got the circles there, but it's only about 5 millimeters. This is going to be one of your really narrow cap capacitors. But there are other types of capacitors. These are going to be your rectangular capacitors. You have to make sure here this is 10 millimeters, about 20 millimeters long, or it's really long. But that's the type of component you'll be putting in, and that's what you'll see when you put it on your circuit board. And I would also advise you don't always take this scale into comparison. Here this is a 62. I'm not exactly sure what the 62 means, but it means something. You could search that up on Google and find out a little bit more about it if you needed to put in a capacitor. Same goes for if you needed to put in an inductor. Same goes if you needed to put in any other type of component. Now there is another component that I think is necessary, and this is going to be your input-output ports. I believe this one's called star star pin. Yep, there it is. So here's star star pin. This is going to give you all of your different pin configurations. So here there's your Mega 8P. So if you wanted to put in a specific type of size of microchip, here this one has what, 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So it's got 28 pins. That's a Mega 8P apparently. And then here you can have a 2-pin, 2-pin, 4-pin, 6-pin, 8-pin, 10-pin, 12-pin. It gives you all of the different pins configuration. That's under the Con-Gary style. You can also have very specific components that you can get the pin configurations for that are in here as well. Now that may not be nearly as useful to you. I'm looking for a very specific type of single pin connector. This 2-pin connector, it works. It gives you 2 pins to work off of. If you have an input-output, you want to just put them together. This would be something where you would probably solder some type of connection onto the board itself so that you could plug in wires. That's useful. Otherwise, you can actually, there is down here, I believe, a single pin header. Well, that one's 3, 6, 8, 5. Okay, that's interesting. This one's 9. Nice. So that's, I guess, the 3, 4, 5, 6, 7, 8, 9. I guess those values all mean, that's what they mean. You can also find other types of pin headers. Really, you're going to want to find something that matches what it is that you want. Now for me, going input output, I usually just typically do not the 3. I go up here and I do the 2-pin 2mm row, dual row, and then what you do is you will connect a wire into both of those. One I have used is the this one right here, which is the 1x1. It's under pinhead. So here, if you do ** pinhead, search for that. Oh, apparently that one doesn't show up. I'm just going to look for pinhead straight up. Okay, that one doesn't work either. ** pin HD. Nope. Okay, never mind. Apparently it's only going to like it if I do ** pin. And then just scroll down until you find the pinhead one, which is going to be down here. Okay, so this one's the one that I usually use. This allows you to just put in a single wire. You can also get these as a set of 2, but again, 2 different types. One of them is bent, one of them is not. Here I would probably recommend if you're going to have 2. This is typically the 2 linked pinheads. This is pinheaders. It's pretty standardized sizing. I would only use that if you have your 2-piece pin headers that you want to connect to. Otherwise, just use your one. You can directly connect a wire into that spot. If you really want to, you can go up here and do the 2-pin dual row connectors. That's another thing. But for this one, I am going to put in 2 of these 1x1 pin headers. So I'll hit OK. Put one here, put one here. Okay, that'll be my input, my output. I could put them right next to each other, but on the schematic it doesn't matter as much. Hit escape, hit cancel, go back to here. Now what I need to do, expand this one more time, draw a net, and I will connect the output of this circle to the input of this wire, and I will connect the output of this circle to the output of that wire. So here now I've got something where I take an input wire, shunt it, have 3 resistors, and it goes out there. Now on my board, every one of the components that I have put down, including the wires, will show up on my board schematic. So you're going to want to make sure that you're completely done with drawing your schematic here before you get started on the board schematic. So here, I'm going to say that this is done for me. I'm going to call this good. Clearly you're going to have your own designs that you're using, probably not 4 resistors in series, but you will want to make sure that you are done with it. Once you are done, first of all, it's a good idea to save. It'll make you name it. I'm going to throw it in the circuit board project file, and I'm going to go ahead and call this shunted resistors. Okay, save it. You'll notice that it changed the name up there. Now once I've got it saved, once I have the schematic all drawn, I'm going to click on this button that says generate /switch to board. When I click on this, it'll say there's not currently a board associated with the schematic. Do you want to create it? I hit yes. What it'll do is it will immediately create this kind of gross diagram right here where you see the yellow wires are showing where your connections are. So that, yeah, I mean, you just gotta know what components you're dealing with and where exactly they lie. So here, this would be closer to my schematic. Now this is my circuit board. So this is the circuit board that comes out right away. These are the sizes for my circuit board. Once again, if you go down to this corner, this is the origin. And I believe this unit, I don't remember what this unit is, but it is not millimeters and it is not inches. It's something like a mil. Let me so here, if I wanted to convert mil to millimeter, apparently it's 1/1000th of an inch. Okay, I did not know that. 1/1000th of an inch. Nice. So here, this is going to be in thousandths of an inch. You'll notice that this goes up to 3, almost 4 inches, and this one goes out to, well, about 6 inches. A little bit bigger than what you need. Don't know how much I trust that sizing, but oh well. So now the next step is we've got our components down here that are imported. You click on the center of them, and drag them into place. Now here, the orientation of your components is going to matter. You do not want to have components facing in weird directions. You also don't want to have them overlapping each other. So, as an example, if I look in on this drawing, this yellow line, as it goes right now, currently crosses this green line. What that means is that I basically am shorting the wire between here and here, the way that this is currently drawn. So I am going to right-click on some of these and rotate them. It works the same way as the schematic. Now here, this did not rotate the orientation that I wanted. I want it to rotate that way. There we go. I'll hit escape. Escape means I'm no longer rotating it. And I'll do the same with this one now. I'll just go rotate. Make sure it is rotated in the correct orientation. Hit escape. Click on this one. I'm going to move it over here, and then I'm going to rotate it 180 degrees. So, just like that. Hit escape. Now, the cleaner your diagram looks, the nicer it will be when it prints. Here, if I just do something like this, where everything's a straight line, nothing intersects, I mean, this is a good schematic. I don't need this giant circuit board. The boundaries of the circuit board, they can change. And in fact, I'm going to want to draw my own circuit board boundary, but you're going to watch me Google that because I actually don't remember how to do that part. That is the piece that I don't know. I've done really good up until this point. Here, it's going to have the same names as all of these. This is actually going to be how it shows up on the board. So everything that's written here on the board is going to show up on the top side of the board. You can have text on the bottom side of the board as well if you have components there. I will not be showing you how to do that right now. Although I think it's just a right click. I think, but yep, not going to be showing you how to do that right now. All of this is just going to show up on the top side. Okay, so now I have all of these components in place. I am going to do something called auto router. Now here you can route an air wire. For professionals, what they'll do is they'll click this. This is basically where you redraw the nets using the yellow lines as your schematic example of what you need to connect. Here I'm just going to hit auto router, and what that'll do is it'll say, okay, here's all the connections that have to be made. Don't put a ton of effort into it, which is why it's low. Use the grid and only have about 8 operating at the same time. I'll hit start. This will be really fast because I lined them up in a circle. So here, 100% optimized, very fast. Hit end job. Now you'll notice that all my yellow lines are red. Red stands for top layer. 16 stands for bottom. We're only doing a 2-layer one here, so we've only set it up so that it only does top and bottom layers. It's cheaper than a 4-layer circuit board, but you can do those if you so like. Now, if you have some schematic where when you hit the auto router, some of them have to be blue, that's okay, because it just means those wires are going to be printed on the bottom side of the circuit board. The issue is you got to make sure that none of your red wires cross and none of your blue wires cross. You want them all to be as straight as possible. You may have to manually go in and delete a wire, so I may have to click on this red wire, hit delete, and then I may have to do a route myself where I connect terminal to terminal. Okay, and that's ultimately how you would do that. Pretty simple. You give intermediate clicks to say here's where I want my intermediate positions to be. So now let me quickly search because I want to know how to change the circuit board shape in Eagle. So this says, I go in here, this is an article written 7 years ago. I want to change the shape of my board to look something like that. The way you do that is you draw what's called a wire in here. Let's see if I can find that. Maybe it's just a line? I don't know. Yeah, I'm going to try a different site for that. It's always fun when, yeah, always fun when you don't know how to do something. Yeah, you can just move the line segments. Here, if you wanted to have a circular board, what you do is, I know you go in here, expand this out, you can draw a circle. I think it's a, oh, there we are, a circle. I think you have to set it to the dimensions layer, I think. Oop, escape. I have to use my selection tool, click on it, change it to dimension layer. I believe that's what you do. Yeah, I'm not terribly certain about that. You will want to make sure that your bottom corner is at 0, 0. I don't have this correct right now. It's still identifying these yellow lines as being the board, so I'm just going to go ahead and delete these. Now you can just use a square. Squares are nice. Squares are delightfully nice. Open up the properties of this, switch it to dimension, hit apply, hit OK. Alright, and then you'll notice that it automatically adjusts to accept that this is the shape that I want. Now I am going to try to center this so that everything is acting in the positive axis, just because that's what I prefer. Go ahead and select these. Oh, didn't want to select the circle. Escape. Try that. See if I can't move it without moving the circle. Ah, dang, it's going to make me move the circle. Okay, I'm going to try grabbing the circle separate. Centering it. Right, and then grabbing everything. There we go. Yay. So now I've got a circular board shape, and you can do this really with any kind of board shape, as long as it's about the right size. Now here, if I wanted to measure this, this point here is approximately 25 mil. This point here is approximately 3019 mil. So that's going to be about 3 inches by 3 inches, which isn't a terribly huge shape. I can also go on here and go to properties. Radius is currently 1500 mil, so yeah, that's going to be 1.5 inches. Just make it a little smaller, make it 1 inch radius. Whoa, no, yeah, whoops. Control Z. I set that at 1 mil. I meant 1000. Up top, me. Okay, now I will go ahead and reset the circle in the center. Just make it nice. Select all of the components. Move this down closer to the origin. And there's my circuit board. Okay, so now I have a circuit board that I am ready to start cutting out. Switch this back to one. Now, when I'm ready to start cutting this out, I've got all of my lines cut in, I've got my board shape in, I've got every one of my components in, I've got my labels in, everything is where it should be. The next step is you have to generate what's called a Gerber file. Now, a Gerber file is it's basically a compressed folder that contains all of the CAM information that would be needed to cut out your shapes and the CAM information that's needed for a machine to go in and put down electrical circuit components. So those two pieces, cutting out your shape, cutting out individual holes, so every one of these through-hole components, right here it has to cut out that hole, and then that green piece will be pasted in its place, which that's just going to be the contact electrode for my resistor as I solder it in place. So all of that will be done with the CAD file, the CAM file. But I'm going to go back on here, and what I'm going to do is I'm going to look at export Gerber file for I want it specifically for JLC PCB, just because that's what I've used in the past. And if you go into, looks like, oh, that's not this. It should be, ooh, nice. Oh, in Eagle for JLC PCB. It'll be the top one. The how to export is as an Eagle file. Oh, this one's not in. Nice, but it goes in steps through the process of how to do it. You are going to need to have a specific file to do it. So the way that I do it is I go to JLC PCB here, this website. This has all the files that you need. So here, we're using the latest version of Eagle, so you're going to use the top one. What you're going to do is you're going to click the top one. This is a 2-layer. We're only working in 2-layer systems right here. So you click on this. Look at all these fun coating pieces. Woo! So you don't click on it. Right click on it, and you should be able to download it. Or right click in here, save as. It should save right as the CAM file. I would delete off the text document or switch it to an all file configuration. Now what this wants you to do, if you go back there, is first I'm just gonna save it in my downloads for now. Hit save, so it'll save into my downloads file. I have it specifically as a .cam file. That's what it comes in as. And if you follow the rest of this tutorial, what it says is okay, for Windows, you need to copy the file into your documents/eagle/cam folder. So if I go in to open up a folder on my computer, first thing I'm going to do is I'm going to go to my downloads folder, right click on this, hit copy, and then I will scroll down, go to my documents folder, or you can go to your specific documents folder. Here's Eagle, here's CAM, and you'll notice I've already got it there. Okay, so just put it right there. Now this will step through the process of how to do all of it. So the first thing we're going to do is click on the CAM processor. I'm going to jump back into my board configuration, go up here to my CAM processor, click on it. Oh, it'll ask me to save it. Always save it. Oh, this is way zoomed in. What are you doing to me? I can't even see the top of the screen. Nice. I don't know why this is so zoomed in. I need to address that at some point. Not addressing it today. What you got to do is you got to go up here, hit load CAM job, CAM JLC PCB 2-layer V9 CAM. So that's the file that we just imported. I have got to figure out how I can actually see this. Oh, there it is. Just had to drag it down. So I will go to load job file. I got my local CAM jobs, CAM. Here's my JLC PCB 2-layer V9 CAM file that I just downloaded. I'll go ahead and click on that. Now, what this will do is it will generate a very, very interesting set of diagrams. So first of all, I've got my board outline. That's an entire layer. Got my top copper. These are all the copper lines that are being printed on the top. These are my bottom copper. This is all of the things that are going to be printed on the bottom. You'll notice it only prints the holes. I got my solder mask top, I've got my solder mask bottom, solder paste top, solder paste bottom, silk screen top. Silk screen is going to be where it prints the outline of the resistors and the names. Silk screen bottom, there's nothing there. Here's the drill files. These are the holes that are actually going to be drilled. Okay, so that's all of that. Now, if I go back into here, I have basically what you do is you take your file and you just save it now. So we'll go ahead and hit export file. I believe that's what you do. Hit export file. We'll go ahead and put that in. I'll put it in my downloads folder. Why not? Select folder. Hit OK. And now, if I open up my downloads folder, shunted resistors.xln. Hell, that's not exactly what I want. I don't want an XLN file. So, instead I have to do something else. Okay, I think here's where... So you load the cam job in here. 3, check it out. There should be a bottom right hand corner. There should be something that says process file. Oh, that would... I can't see it. Right. So I hit process job. That's okay. That's right. And I'm going to save this in my downloads folder. So it'll save as a zip folder. So I'll just hit OK. OK. And then I'll click out of this window. Make sure to save this. And I'm done with Eagle. So just created my own little diagram in there. We're done. All right, now that I have that, I go to jlcpcb.com because that's the prototyper that I use. They have really, really cheap boards. I'm going to go to order now. What it'll do is this will send me to a place where I can add a Gerber file. My Gerber file is going to be that zip file that I just saved. So I'll go back to my downloads, shunted resistor, hit select, hit open. It'll take it a little bit for it to process, but once it does, you will notice that you have a few options. It comes in, it shows my circle, it shows each one of my components. Here it has all of the screen printing on it. It has all of the holes drilled, it has all of the copper wires made on it. Here's the top view, here's the bottom view. Well, that's kind of cool. You'll notice that the price for this is $2. They do $2, and what it'll do is it will automatically give you 5 circuit boards. Now you can select different colors. Yes, different colors take a little bit longer to process, but you can do that. And you have a few other things. I personally wouldn't touch anything else other than maybe the color. You can change the number of PCBs that you want, but it has to be a quantity of 5 or 10. Change it to 10. I mean, it's just more cost effective to do 5, personally. Well, it's supposed to be 4. It'll only give you a $2 rate, which is really nice. And then you go ahead and save to cart, and you'll order from there. As long as you can give your instructor the zipped folder containing your file, that is all that they should need to be able to order this for you. So that is my overview of how